This is Mr. Campbell. This is Algebra 1, 1.6 Compound Inequalities. Compound inequality consists of two or more inequalities The two types of compound inequalities are and or problems, and or inequalities. I can use inequalities to best describe this set of numbers. Whenever they don't connect, it's going to be an or problem. So x is going to be less than or equal to -3, and x is greater than 2. So we put an or there. That connects the two. So x is less than or equal to -3, or x is greater than 2. This one here, it's connected, so it would be x is greater than or equal to -4, and x is less than 1. Ands connect. So you could also write it like this. Either one would be correct. So the compound inequality for this one would be x is greater than -2. They connect. It's like two hands connecting, okay? X is greater than -2, and x is less than or equal to 6. You could also write it like this. These mean the same thing. Either one would be correct. So we're going to solve this compound inequality. This is an OR problem. So add 7. So 5x is less than 20. Divide by 5. X is less than 4. And or, this in here I'm going to subtract 3. So I get -4x is greater than 8. Divide by -4. When you divide by negative, both sides of an inequality by negative, you need to reverse the inequality. So that gives me x is less than -2. So this is an OR problem. So let's graph this thing. So we have x is less than -2. Here's 4. Here's -2. So x is less than -2. So open circle going this way. And x is less than 4 going this way. Now, OR means everything, okay? So everything on this one here would be everything going this way. They don't share points down here, the two inequalities. They only, and that's not that important, but to make up the whole graph, the solution would just be x is less than 4. If this was an AND problem, then they would only intersect from -2 over. Okay? Your final solution would be this, all real numbers less than 4. So your final graph would just be this here. Open circle and going this way. So again, OR would be everything. If it was an AND, it would just be here. AND means intersect. And so your final solution is just this, all real numbers less than 4. So it'd be an open circle at 4 and going to the left. Here's another AND or another OR problem. So I subtract 4. Then divide by -1. Got to reverse the inequality. Then OR, let's do this one, add 5. So 2x is less than or equal to 12. Divide by 2. X is less than or equal to 6. So let's graph this. 0, 7, 6. So x is greater than 6. It's going to be going this way. And x is less than 6, less than or equal to 6 is going this way. So this one here, to make up everything, this is the solution. And this is the graph. ORs are a little unique. They go in opposite directions most of the time. Not the last one we didn't do that, but most of the time that's what they do. So let's do this one here. Subtract 2. I get negative 3x is greater than negative 9. Divide by negative 3. Have to reverse inequality. Or, now let's distribute here. So that gives me 2x minus 4 is greater than or equal to 6. Add 4. So I get 2x is greater than or equal to 10. Divide by 2. X ends up being greater than or equal to 5. So we go to graph this thing. 0, 3, 5. X is greater than or equal to 5 is this way going this way. And x is less than 3 would be an open circle going this way. So that is the solution, and that is the graph of an OR. Okay? Example 3 is more of an example of a AND problem because you have endpoints. So I'm going to subtract 9, but I'm going to subtract 9 from everything. From here, from here, from here. Those cancel, so that gives me negative 21 is less than or equal to 7x, which is less than 7. And then now I'm going to divide everything by 7. So I get negative 3 is less than or equal to x, which is less than 1. So negative 3, 0, 1, open circle, close circle, and connect those two. Ands are normally connected like this. I'll do it again because I get cut off here. So x is greater than or equal to negative 3 is going this way, and x is less than 1 is going this way. So they intersect between those two. Like x is greater than or equal to negative 3, it keeps going this way, and then x is less than 1 goes this way. It's ands are only where they handshake, where they intersect together. And means intersect. Okay, here's an AND problem. So we're going to add 5 to both sides. So we get 2x is greater than 8. Divide by 2. X is greater than 4. And subtract 7. So negative 4x is less than negative 32. Divide by negative 4. Got to reverse inequality. Negative 32 divided by negative 4 is positive 8. So remember, x is greater than 4 is where they intersect. So we have 0, 4, 8. X is greater than 4 is going this way, and x is greater than 8 is going this way. So the only place they intersect, they don't share points down here. This is an AND. So your actual solution would just be x is greater than 8. That's where they intersect. They intersect it from 8 over. So your only graph would be open circle going this way. They do not share points there. If it was an OR, it would go from here over. Okay, so we distribute. Add 2 to both sides. Okay. Divide by negative 2, have to reverse inequality. Subtract 1. And always feel free to, pause the video and work a little bit ahead and see it, then watch me do it and see if you're doing it correctly. That's a great way to learn. Okay, so it's an AND, which means intersect. So 0's here, negative 3's here, we'll say negative 1's here. So x is greater than negative 3 is everything going this way. X is less than or equal to negative 1 is everything going this way. So they intersect between these two. You could write it like this as a solution. You could also write it like this. Can't do ORs like that, but you can write ANDs like this. Okay. and then your graph is where they intersect. You can write it either way. Okay, example 4. Okay, this is the last example for this one. Example 4. Enrique plans a diet for his dog. River consumes between 510 and 500 calories per day. If River eats 1.5 servings of dog food, how many treats can she have? Okay, so if she's eating 1.5 servings per day, I'm going to let X represent the number of treats River can have each day. So X equals number of treats River can have per day. Okay, so each calorie, each serving is 320 calories per serving. So if she eats 1.5 servings of dog food each day, 1.5 of 320 equals 480 calories per day. So if I want to write, and River consumes somewhere between those two per day. If River eats 1.5 serving of dog food each day, how many treats can she have? So I'm going to let X be the number. So there's 15 calories per treat. Okay, so we could write 480 calories plus 15x. 15 because each serving or each treat has 15 calories. And she wants it to somewhere between 540 and 510. So we have a compound inequality here, and this is an and problem, so I'm going to subtract 480 from everything. So those cancel, so that gives me what? 30 is less than or equal to 15x, which is less than or equal to 60. And then I'm going to divide everything by 15. So 30 divided by 15 is 2, and 60 divided by 15 is 4. So River can eat at least 2 and no more than 4, and at most 4 treats, correct? So she can eat 2 up to 4 treats per day. That's 1.6 notes. Don't worry about these other ones.